You know, every single day we walk past dozens of things that are designed to save our lives. We just trust them. We put this incredible unspoken trust in them, just assuming they'll work when we need them. But have you ever really stopped and thought about what's behind that trust? Well, that's exactly what we're going to dig into today. Right, think about a fire extinguisher. It just sits there on the wall for years, totally ignored. But in that one moment of absolute crisis, you are literally betting your life that it's going to work perfectly. So, what's the difference between a life-saving tool and a useless red can? The answer, in a word, is testing. And that brings us to the core of this whole thing. It's this unspoken promise. When you see a piece of safety gear, there's this built-in guarantee that it's going to perform flawlessly under the worst conditions imaginable. But how is that promise actually kept? Yeah, that guarantee, it's not just a sticker, it's not just a label, it's something that's forged in fire and under immense pressure. It comes from a hidden world of incredibly detailed, rigorous, and honestly sometimes brutal testing. So, let's pull back the curtain and dive right into that world. So, where does all this even happen? Well, it takes place in these highly specialized laboratories. And look, these are not your typical labs with a few beakers and test tubes. No, these are custom-built proving grounds, designed for one reason and one reason only, to see if this equipment can actually live up to its promise. And you don't just throw one of these labs together. Building one is a massive undertaking. It's this super meticulous four-step process. You start with the architectural design. Then you have to find and buy all this crazy specialized equipment. And then you have to install and commission it all. But maybe the most important step, it's the last one, training the staff so they are absolute experts. Because in this line of work, you just can't leave anything to chance. And here, take a look inside one of these proving grounds. You can see right away this is not your high school science class. These are seriously controlled environments built to create the absolute worst-case scenarios you can think of. The whole point is to push this equipment way, way beyond anything it would ever face in the real world. Okay, so we've seen the arena. Now let's get to the main event, the trials themselves. This is where the stuff inside the extinguisher and the extinguisher itself get put through the ringer. First up, let's talk about firefighting foam. We've all probably seen this stuff in movies, used to fight huge liquid fires at places like airports. But here's the thing, not all foam is created equal, not even close. Its performance all comes down to some very specific physical properties. To really get what makes a good foam, you have to look at three key trials. It's not just about making bubbles. First, there's the expansion ratio. That tells you if the foam can spread out fast enough to actually smother a fire. Then you've got burn-back resistance, and this one is absolutely critical. It keeps a fire you thought you put out from suddenly and dangerously flaring back to life. And finally, there's drainage time. That measures how long the foam blanket will actually stick around. A weak foam can just collapse in seconds, making it totally useless. And believe me, this testing gets unbelievably precise. We're talking down to the molecular level. Technicians are in there analyzing the foam concentrate, measuring its exact chemical makeup, things like viscosity and pH. Every single drop has to be perfect, or the entire batch fails. Okay, let's switch gears to something we're all a bit more familiar with. The dry chemical powder you find in those common ABC extinguishers. Now, you might think, it's just powder. How complicated can it be? Well, making sure that powder actually works after sitting on a wall for a decade, that's a whole other science. See, the biggest enemy of dry powder is just time. Over the years, gravity and humidity can make it clump together and basically become a useless brick. That's why the caking test is so important. It literally simulates years of sitting still to make sure the powder stays, well, powdery. The flowability test makes sure it sprays out in a fine cloud instead of clogging the nozzle. And they check the moisture content obsessively, because even a tiny amount of water can cause corrosion inside and lead to a catastrophic failure. But hey, what good is the perfect foam or the perfect powder if the can it's in fails? Exactly. The extinguisher itself, the canister, the hose, the valve, the whole shebang is just as critical. And you better believe it, it has to survive its own set of brutal trials. Think of this as a complete mechanical stress test for the entire unit. In the hydrostatic test, they intentionally overpressurize the cylinder to a level it should never ever see, just to be positive it won't explode. They time the discharge down to the millisecond, they use special gear to hunt for microscopic leaks, and they test the valves and hoses until they literally break. Every single component has to be perfect. So, let's say a product has survived all of these brutal tests. It's passed.
What happens now? This is where things get official. The lab's results have to be validated by an even higher authority to earn a global seal of approval.
And that seal has a name. It's called accreditation. Basically, it means an independent, authoritative organization has come in and audited everything, the lab, the equipment, the staff, the procedures, and has officially certified that they are competent and the results are trustworthy. Accreditation is the ultimate proof, the final seal of approval that says these tests can be trusted anywhere in the world.
And this isn't just some local standard either. These labs are all following a global rulebook on what safe actually means. Organizations like ISO, NFPA, and others write that rulebook. It's what ensures that a fire extinguisher tested in India is held to the exact same high standard as one tested in Europe or North America. It's a global consensus.
So, let's bring this all back to where we started, that simple red can on the wall. Turns out, it's not so simple after all, is it? It's really the final piece of a massive hidden safety net.
From the way the lab is designed, to the chemical analysis of a single drop of foam, all the way to the global standards that tie it all together, this entire invisible system exists for just one reason, so that when the absolute worst happens, you can have total confidence that the tool in your hand is going to work.
And it kind of makes you wonder, doesn't it? From the seatbelt in your car to the circuit breaker in your house, what other life-saving devices that we just take for granted depend on their own secret world of testing to keep us all safe?